In this lesson, we're going to be graphing cosine functions. So let's take us back to our notes, our intro notes, when we graphed cosine x from a t-chart. So cosine x looks just like sine x, except it's been shifted. So what we're going to work with are the key points. So notice that these key points are somewhat different than the key points for sine. So these are going to be the key points that we're going to make changes to according to our a through d values. Everything else is the same. The amplitude is the same for a cosine function as it was found for sine, and period as well is the same for cosine functions. We find the period of cosine functions the same way we did for sine. All right, and just a reminder, if we encounter any cosine functions where we have both b and c values, it's first important to factor out the b. All right, let's get to some examples. All right, so the first thing I'm going to do is come down here and look at the new formulas for my transformed or my new points. Pardon me. So first, let's identify a through d. So we're going to start out easy. We should see that we're just going to vertically stretch the parent function by a factor of 3. So the y-coordinates will change, but nothing else. So now we'll come down here and use our formulas for x and y coordinates. So 1 over b is 1 times x plus 0, a, which is 3 times y plus d, which is 0. So no changes to the x coordinates, but all y coordinates are going to be tripled. All right, we're dealing with cosine. Cosine starts at the point not 0, 0, but 0, 1. The x coordinates go by half increments. So that key point is 0. Then we're at pi, -1. Our other x-intercept here. And then at 2 pi, we end again at 1. All right, let's generate the new points. So the x's stay the same. Let's just triple the y's. So that's 3, etc. That's still 0. Still 0, and that's going to be 3. All right, thinking about how we're going to scale the grid, I'm going to go from 0 to 2 pi, as high as 3 and as low as -3. I think I'll let two tick marks represent the distance from 0 to pi over 2. 2 more. Hopefully you're comfortable with this. It's just the graph's going to start, a little differently than the sine. And then the y-axis, I'll just let one tick mark indicate a unit of 1. All right, so 0, 3. We're going to end at 2 pi 3. Halfway between the beginning and this is the end, halfway between at pi, we're going to bottom out at the minimum. And these other 2 points are going to put us on the x-axis. Okay, again, be careful how you draw this. It should swing this way, and then when you hit this x-intercept, we have to swing it back in this direction. We'll get this x-intercept, and then we want to swing it back to get that other maximum point. Okay, the amplitude is the absolute value of 3, which is just 3. Starts at x equals 0, ends at x equals 2 pi. If you subtract this bigger x minus that one, we get 2 pi, which, remember, that is equal to the formula 2 pi over b, and b is just 1. What was d? Oh, x-intercepts. We do have them. We record them. All right, for E, it's going to be the maximum is y equals 3. Now, in this particular graph, notice that maximum occurs at 2 different x values. So the maximum of 3 is going to occur at x equals 0 and x equals 2 pi, and we should record both those. And the minimum is y equals -3, but it only occurs at pi. Domain. and range. All right, moving right along, let's look at example 8. So B is 1/2 and no C or D values. So let's just think about what change to the parent function is going to take place. Well, we're not vertically stretching or shrinking because this coefficient is still 1, but this 1/2 here is going to actually reduce, oh, actually it's going to extend our period. It's going to make our period bigger. I know it's weird that you have a number less than 1, but on the horizontal changes, it's kind of opposite of intuition. All right, we'll see what happens. All right, so 1 over B, 1 over 1/2 times X plus C, A times Y plus D. We know a whole divided by half gives us 2 X's, no changes to the Y coordinate. So we're just going to double all the X's of the key point and keep the Y coordinates the same. So where am I at here? Double the X's, well, it's still 0. Keep the Y. If I double pi over 2, I'm going to get pi, 0. Double pi is 2 pi. Keep the Y. I see the trend of the X's are that they are increasing by pi, so I feel safe in saying this is 3 pi, and this last one is 4 pi. Okay, let's think about how we're going to scale 0 to 4 pi. As low as -1, as high as 1. All right. So I will maybe do 2 tick marks for a pi. Probably could have done 3. Whatever you want to do. As high as 1 and low as -1, so maybe I'll use 2 tick marks. So 0, 1, pi 0, etc. Looks like this. Make sure you swing the graph this way, but when you hit this x-intercept, it's got to swing backwards, bend backwards. That's concavity is what we call that. All right. At this point, I'm going to have you guys fill this in, so you might want to stop the video, fill this in, and then once we've completed all the examples, we can check my key to make certain that this is correct. Let me just remind you that up here when you get to the maximum, you're going to have 2 x values where y equals 1 is the max value. So here for part E, you'd have y equals 1 at x equals 0 and at x equals 4 pi, as suggested by your graph and your points. But to save time, I think I'll let you guys do those on your own and then check my key. Let's go to a few more examples. If you're comfortable, stop the video, complete these on your own, and then check my key. I know A is -2, but the amplitude question is +2. Ooh, B is 6 and no C or D's. They're coming. Formula, 1 over B, 1 over 6 times X plus 0, A times Y plus 0. However you want to write this as X divided by 6, but it's the same thing as multiplying by 1/6, comma -2Y. That look right? Yep. All right, let's see. I think I'm going to, because these are kind of complicated, I'm going to manage the x coordinates first and then come back and multiply all y's by -2. Well, I guess that's not too bad. We'll see. 0 divided by 6 is still 0. Yeah, I'll just do the whole point. This is -2. All right, pi over 2 divided by 6, but pi over 2 divided by 6 is the same thing as multiplying by 1/6. So pi over 12. Yeah, that's pretty pretty narrow. 0 times negative is still 0. All right, pi for x, since this is not a fraction, pi divided by 6 is just a sixth of a pi, and this will become positive 2. 3 pi over 2 divided by 6, but instead I'm going to multiply by 1/6. So divide out 3, we get pi over 4. And still 0. And then 2 pi divided by 6 is pi over 3. And then negative 2. So it looks like the x's increase by 1 pi over 12 as you advance through the points, the new points. Looks like I'm adding 1 pi over 12, and that would make sense if I reduced, I would get these x values right here. Okay, it looks like my point's going to start below the x-axis, so it looks like we have a reflection, and that is true because of that negative sign. All right, let's see. I'm going from 0 to pi over 3, so it's very, very thin this way. The period has to start at x equals 0 and end at 1/3 of a pi, so it's very crowded on the graph if you were to use your calculator. But I think I'm still going to just use 2 tick marks for each of these consecutive x values. So this is 1 pi over 12, 2 pi over 12, 3 pi over 12, which is pi over 4, 4 pi over 12, which is pi over 3. Yeah, as low as negative 2 and as high as 2, so I think I'll just use 2 tick marks for each one. So it's not too crowded. So 0, negative 2. Got a 0 here, and I got a 0 here, don't I? Pi over 6 is up here. Pi over 3 is down here again. Concave up, concave down, still concave down, and then concave up. Again, I'll let you fill out all this information, but just notice that on the F question, you have a minimum of y equals negative 2, and that's going to occur at 2 x values for this minimum question at the beginning and end of this period. Now the maximum, you'll just have it at one location, and that's at pi over 6. So y equals 2 is the max at x equals pi over 6. Just because that graph's been reflected, that's why those kind of switch from the previous ones. Let's continue. Let's look at example 10. All right, A is 1, B. Now B is the number in front of X, and notice that that's just 1. So I don't have to factor any B out. I don't have to make any changes on pi over 4. So since B is 1, C is actually going to be pi over 4. Remember, the C value is opposite of the sign that's in parentheses. And it doesn't look like we have a translation up or down, so D is 0. So 1 over B times X plus C, plus pi over 4, AY, so that's 1y plus 0. So we've got X plus pi over 4. And no changes to the y's. So what that tells me is that all my x coordinates are going to increase by pi over 4, so I must be shifting to the right pi over 4. Okay, y's don't change, just add pi over 4 to all the x's, so that would be pi over 4, 1, comma. All right, pi over 2 plus pi over 4. All right, common denominator. That'd be 3 pi over 4. Right. I kind of see a pattern already with these two consecutive x values. So this is 1 pi over 4. If I added 2 pi over 4, I'd get to 3 pi over 4. I'm just betting that this is going to be 5 pi over 4. Now I can confirm that by putting a whole pi in for x and adding pi over 4. And that makes sense because this would be 4 over 4 and that'd be 5 pi over 4. So if you see that trend, well, then it might make your work a little bit easier, less computation. So if this is 1, 3, 5, the next x value will be 7 pi over 4 with a 0. And then here, seeing the trend 1, 3, 5, 7, the next one will be 9 pi over 4. Which makes sense. If you add 2 whole pi and a fourth of pi, you should get 9 pi over 4. Now let's think about how we're going to scale this. Well, I start a little bit past x equals 0, so maybe I'll put the y-axis about right here. All right, and now, so pi over 4 is where I start. I think I'm just going to let one tick mark be a pi over 4. This would not be 3 pi over 4 because that distance would be 2 pi over 4 and the distance would not be the same from the y-axis to here. This is 1 pi over 4. I can't put 3 pi over 4 here because that'd be a distance of 2 pi over 4. You wouldn't have the x-axis scaled right. So let's let this be 3 pi over 4. So if this is 1 pi over 4, 2 pi over 4, 3 pi over 4, got it, 4, 5 pi over 4, etc. 9 pi over 4. All right, so, and what are the y's? 1 to -1. So I don't know, I'll let 3 tick marks be a distance of 1. So pi over 4, 1. 9 pi over 4 will end there at 1 also. 5 pi over 4, halfway between these 2 points right here, I would bottom out at -1. And then I've got 2 x-intercepts here. Okay, and then again, I'll let you fill in this information right here. Just notice that for the maximum of y equals 1, it's going to occur at the 2 endpoints at x equals 0 and x equals, or excuse me, at x equals pi over 4 and at x equals 9 pi over 4. All right, and last but not least, let's graph this more complicated equation here where we've thrown everything in. All right, so we're going to vertically shrink it so the graph won't go as high as 1 or as low as 1, a -1. Okay, what is b? B is the coefficient here, so that's going to be 1/2. Okay, we got to stop here. Now c is not pi, or negative pi, excuse me. C is not negative pi because I have to factor that 1/2 out. So y equals 2/3 cosine. I'm going to put a bracket here. Okay, after cosine, I'm going to take the 1/2 out in front of the x and then build a parenthesis here. All right, so I'm going to put an x here. So if I distribute that half back in, I will get x over 2. What do I need to put here? So when I distribute 1/2 to that, I get pi. Well, it looks like that's going to be 2 pi because a half times 2 pi is a pi. All right, so now c can be thought of as -2 pi and d is 2. So vertical shrink, we won't go as high as 1 and low as -1. Horizontal stretch, because our period's going to be wider, longer. We're going to shift to the right, or excuse me, left 2 pi, it looks like. Yeah, left 2 pi, wow. And then up 2. Ooh. All right, let's see what happens. 1/2 x plus -2 pi, but I'll record it as -2 pi. Plus your c, but it's negative. And then a, y, plus d. Yeah, we've done one of these. All right, let's clean this up. This is 2x minus 2 pi. Actually, I think we did this with the sine graph. I think this is exactly what the changes were to that sine example earlier. All right, right, pretty complicated, so I might just tackle the x-coordinates first. We'll see. And then the y's later. Let's see. Okay, so my first x is 0. That's still 0 minus 2 pi. So I'm going to start it in x equals negative 2 pi. I'll go ahead and tackle the y's. Let y be 1, so 2/3 plus 2. Well, that's just 2 2/3, or 8/3, but might as well just write it as 2 2/3 so I can graph it. All right, pi over 2 here, double that, that's pi. A whole pi minus 2 pi's is negative pi. Y is 0, that's just going to be 2. All right, our next x is pi, so 2 pi minus 2 pi. Oh, we finally made it to x equals 0. Negative 1 times 2/3 is negative 2/3 plus 2. Negative 2/3 plus 2. Well, that's going to be 1 1/3. Yeah, just like our last example. Or 4/3, but since we're plotting points, we might as well change it to a mixed number. Where are we at? I see the trend of the x's, so instead of doing the formula, I can say, hey, my x's are increasing by a pi, so I should be over here at positive pi. That 0 means I have a 2 here. Increasing by pi, this, double that, 4 pi minus 2, but yeah, 2 pi here. And then 2/3 plus 2 is, again, 2 2/3, so that's going to be our maximum. All right, so let's take a moment, pause, and think about how we're going to scale this. So let's see, what do? We go from negative 2 pi to positive 2 pi. Well, that's convenient. I might put the y-axis right in the middle of this grid then. Oh, and before I draw the x-axis, let me think about my y-coordinates. It looks like the smallest value is 1 1/3 and the biggest is 2 2/3, like the last example. So I might actually put my x-axis down here. Oh, no, that's fine. Okay. All right, so this is my x-axis right here. You don't have to. I mean, you could keep your x-axis here and then just do like a 1, 2, and then maybe go off the grid a bit, or let each tick mark be a 1. But I'm just going to put it down here so I can see the graph. All right, so negative 2 pi and 2 2/3. Oh, I got to figure that out. All right, negative 2 pi. I think I'll use 2 tick marks. So that's negative pi. Probably could have used more. Yeah, I could use one more. That's okay. All right, so that makes sense. Pi and negative pi are on opposite sides, equidistant, and this is 2 pi. All right, so I need to go from 1 1/3 to 2 1/3. So maybe this is 1, this is 2, and this should suffice up to 3. All right, negative 2 pi and 2 2/3. So 2, 2 1/2, but 2/3 is more than a half, so right here. Might as well go ahead and get the end point at 2 pi up to 2 2/3. I might do the midpoint, 0 1/3. So 0, 1 is here, 1 1/2 is here, so 1 1/3 is probably here. So 2 maximums, well, 1 maximum occurring twice, and then a minimum. All right, and then negative pi up to 2. It must be positive pi up to 2. There we go. You'll know if you did something wrong over here because your points won't line up like they should to produce the cosine graph. So bend down, concave down, turn the graph concave up. When you get here, we start to kind of bend back down like that. Okay, and again, we're going to fill this information in, and once you complete that, then we can check with my key. Remembering that y equals 2 2/3 occurs at x equals negative 2 pi and at x equals positive 2 pi.